Just a minute. Okay, yes. So today we'll cover functions. Okay, we'll see. We'll not be able to cover everything about function in this session, because if I'll cover everything, it may go more than around 2 hours, because there are lots of things I have. So I'm breaking this into two parts. Today we'll see how function is and the scope things, how scoping
Sorry,
works in Python. Yes.
sorry for the interruption, Dheeraj bhai. So, can you just zoom in your system because it is very
Sure,
important?
sure, sure. I'll zoom in these forms.
Yeah.
Settings. I'll have to find out.
Is this the PyCharm or what is
This is Visual Code.
that?
I don't know how
So,
it
can you
is
please
open.
enter control plus control?
No, no, it's not. Okay, it's complete the screen. So okay,
Yeah,
it's okay.
yeah, that is
Let me do
fine.
like
Yeah,
this is fine, right?
yeah, fine. Thanks.
Okay. So let's start functions. As this, functions are a group of statements. Okay, we can write multiple statements in which are related to each other in a function, and we can use those functions wherever we need. So the one very useful benefit of having function is we need not to write everything again and again. We can write a function and we can use it. Python, we have a different way to write a function. We write a def keyword. Okay, it's a
Dheeraj bhai,
executable statement.
I'm not sure whether all the participants are visible very clearly. Again, it is zoom out. So if you can zoom
Okay,
in a little bit more, that would be
is
very.
it fine to everyone?
Yeah, now it is much clear. Thank you.
Okay, okay. So in Python, we have this def keyword, and this keyword tells whatever we are writing after this, it is a function. Okay, so and def is a executable code. Okay, let me add some points here, and after this we'll see how we can create a function. So this is def is a executable code. It creates an object and assign it to a name. Means whatever function we are creating, so def will create one object, okay, function object, and assign that object a name, which we say function name. Okay, so it generates a new function object, assign it to the function name. As with all assignments, the function name becomes a reference to the function object, as other variables and everything we saw earlier, that in Python, everything is a reference, means the name, the variable name which we write, that is a reference which refer to a object. It is also applicable in case of function. So in memory, there somewhere that function object will reside, and this function name, what we give the name, this function name will refer to that object, to that address. Okay, we'll see all these in code. Okay, then lambda creates an object but returns it as a result. So we'll see lambda in detail in next session, not today. Okay, return sends a return object back to the caller. So every function means it's not compulsory to that function will return something, but it can return something, and resulting object it will send back to the caller, whoever is calling this. There is one term yield. This also we'll see later on how to use it. Okay, in next session we'll see how this yield work. Okay, then there are different things like global declares module level variable that are to be assigned. We'll see today what global are, means it's a global, how we will declare global variables. Okay, we'll see that. Assignments are passed, arguments are passed as a by assignment. Okay, means by reference. Arguments are passed by position unless you say otherwise, means there are two ways we can pass arguments into a function. Okay, so one is direct normal reference way, through object reference, and there is another keyword based parameter passing. That is a different way to pass a parameter. Arguments, return value, and variables are not declared. Nothing about a function need to be declared ahead of time. Okay, so whatever as we know in Python, we don't declare anything. Okay, everything is when we are creating a memory at that time. Uh, means we use the means before using we'll have to add something, initialize your variable. So it's not like in other language we write int x or a string str like that. It's nothing like that in. So those all rules are applicable here also. So let's see how to write a function, means what is the exact syntax. So we write a def, it is an executable. Now we give a name to our function with this, and we pass two arguments. Okay, again up in Python, as we saw in case of if, for, we used colon. Here also we'll use colon. Now let's return x into y. Okay, so let's call this function with two values, 2, 10, but we'll have to print it because we are not printing anything inside. Let's run this. Okay, this is simple function we called and we got something in return. Now let's see, as this line says, def creates an object and assign it to a name. So let's see where this object is. So we can check that the type of the object. First we will see what is the type of the object. So the type of the object is function class. Okay. So this is a function class object. Okay, now let's see the object, where this object is. So id is a function which gives us the address of the object. So here you will see this is the address of the object. So what this first line says, it creates an object and assign it to a name. So this is the object which is assigned to this name. Clear that line? So if we create another function now, create another function means, let's say we redefine this function. Now instead of into y, we'll see we'll do x plus y. Now again we'll print everything. So this visual code is giving one warning that function already defined here in that line number 26. But we'll see, because this is what we want to check. What happens if we do this? So you will see this first one, when we call this first function, we created x into y. It got created, the object got created at this address. But this second function, it got created at another location. Okay, so if you by mistake or something, if you do this kind of thing, you will lose this function object. Okay, so there is one statement I'll make here. Because function definition happens at a runtime, there is nothing special about function name. What's important is object to which it refers. Okay, so when we write like this, okay, this will create an object. Okay, but it will not execute until we'll call this function. Okay, so we can write like this also. What this will do is, what we are doing, we are just doing assignment. Yes, there is a function class object and we are assigning it to another name. This will again also, this will also start pointing to this address. Let's check it. See, both objects are pointing to the same, means though both name variable names are pointing to same object, right? So if we write like this, and we can call it using this function like this. I print it. It will print. Okay, it will take two parameters. So again, it's same functions. It will take two parameters. We'll have to pass that. Let's run this. Same object. Everything is same. Clear? Okay. So in Python, every operation, whatever function we write, those are polymorphic. Okay. When I say polymorphic, it means I can pass any type of variables to that function. For example, if I use this function only, and I'll add a string. Okay. So this is the polymorphic nature of a function. This will work until and unless whatever type of object we are passing it supports this operation. For example, in our this function we have plus operator used. Plus, just a minute, guys. Sorry, guys, my daughter was here. So okay. So what I was saying is, until those objects are supporting these type of operation, whatever we are doing inside it, these functions can take those as a parameter, which we need not to write something integer string or something. So these are polymorphic by nature. Okay. Is it clear till now, everyone?
Yeah, Dheeraj.
Okay.
Yeah, Dheeraj.
Okay. So this was something basic. Now let's see. Let's write uh, write a function which will do something more than just adding and multiplying. So let's say we have this function intersect. Okay. And what this function is doing, it is creating one empty list inside, and then it is running looping here on the first argument we are passing, and it is checking if the words, if the characters in this sequence, or not character, if the element if whatever is in present in this sequence 1, if it is present in sequence 2 also, it will add into a in this list, and it will return a list. So this is what this function will do. Let's create two variables here. So these are two strings. Okay. And we'll call this, will print whatever we are receiving, will print here. Okay. Here it is printing the whole list, and you can see all the characters which are common in these two parameters we passed, sorry, arguments we passed. So it is listing all those characters here. Okay. We can collect this into some output variable. Okay. And we can print it also. Let's see. So means whatever is function is returning, if function is returning something, we can collect it into some variable, and then we can print that. In this case, means as this is a list of characters, so let's create it, convert it into a string so that it will be more readable. Okay. So let's write this. I hope everyone remember this function, this syntax. What this will do is, it will join all the elements which are present in this list with this value. So because we are not passing any character, so it will create one string like this. You can see these all elements are common in these two functions. Test string. Okay. So this is what this function is doing. So we likewise we can do anything inside a function. We can return anything from a function. Okay, and we need not to write any return type or function in Python. Okay, like in other languages like C and C++, we used to write a return type for a function. So in Python, we need not to do that. Okay, we just add this def keyword. It will create one object, function object, and assign to means this name. This will refer to that object. Okay, we can pass more than one parameter here. Means sorry, return more than one parameters.
So there is why here,
Yeah.
like the text, whatever it is displaying in the yellow color, is this the
Mhm.
predefined? There are two
Uh,
things. One is in the blue color, that is the function name, and one
uh,
is yellow
yeah.
color.
See, this blue color is not a function name. This is a keyword. Okay,
Oh,
and
yeah.
this is a function name. This print
Okay.
is a function name. Okay,
Okay.
don't
Okay.
don't consider these colors because these colors will vary from uh, your editor to editor. Okay,
Okay. Got
yeah,
it.
means you can write these code using a simple notepad.
Mm-hmm. Oh,
Okay,
yeah.
so don't go focus on colors. Okay,
Okay.
yeah, so these are keywords. This def is a keyword, print is a function.
Yeah.
Okay, join is also a function. Okay, so you will see join is a function, but it is not in here local. So don't go on colors.
Okay. Okay.
Okay,
Yeah. Thanks.
so as okay, I was showing you how we can return multiple things. Now we have L. Yes. Okay, so in this line, this printed one tuple of one this list and other list is this. And here when we collected it uh, into two variables, we got two different lists. Okay, so function, if you are passing returning more than one values from function, it will return as a tuple. Okay, and when you are collecting those values here, it will unpack this tuple and it will assign one by one. In the order you are passing these variables here, in the same means first element, first value which is coming in return type, it will assign to the first variable, and second value you can collect into a second variable. Okay, so likewise you can return more than let's see, you can return one tuple. See, you got the tuple, so you can return any number of values. Okay, we got this error because too many values to unpack. I told you. we unpack it here. When this whatever this function is returning, it gets unpacked when we collect those that value uh, in variables. So because we are not giving three values, we are returning three values from here, but we are passing only two variables here. That's why we are getting this error. Okay, I hope it is clear till now. So as I said that all the functions are by default polymorphic in nature. If I pass one list and one tuple here, again it will be okay. It will work. Okay. First is the intersection of this list and tuple, and second is this value we are passing, we are returning. Okay. Second list is this list, and first is intersection of these two. So 2 and 3 we are getting here. Okay. So now we saw some basics of uh, function, how function is, some basic properties. Now let's see the scope of variables. What are all the what all scopes these variables have? Okay. So variables. Now we'll start scopes, variable scopes, and you can see this triple quote. I'm using it for documentation purpose. So this is right now we can see. Okay. So variables may be assigned in three different places. One, inside the def. Okay, it's local to that function. Okay. Another is assigned in an enclosing def. It is a non-local. We'll see that later on. And third one is outside all def, means outside all the functions. Okay, it will be a global variable for a file. Okay, we'll see each one by one. Okay, so let's see some example for local variables. We'll take that earlier function, for example. It's a scope function, and whatever we are doing, that is same we are doing inside. It is same as this one. Okay. Now call this function and let's see the output. It's from inside here. It is printing 2 and 3, and outside, because outside it is the output of it. But this res, it is a local. Okay, what we are printing here, it is a local variable to this. We cannot access this outside this function. If we do this, get name res is not defined because it is inside the scope of this function. So what happens when we create a variable like this in a function? It creates one stack. Okay, these variables get memory in that stack, and as soon as execution comes out of this return function, this statement is executed and function returns the value. This stack gets cleared and this variable get destroyed. Okay, so this is the reason we cannot access that outside this function. Okay, and if okay, so you got it. This is a local variable. Okay.
So one question here, Dheeraj, regarding this
Mhm.
return.
Mhm.
When we say return rest, so you said that we cannot use it outside here. So print rest will return us something, right?
See, what we know in Python is everything is as a reference. All the variables names, they are reference to some memory,
Right.
right?
Yeah.
So if you think it like this, if I'm writing it like this, okay. So what this will do is this variable is referring to some object, right?
Right.
What I did, I copied that reference to this variable. Now this variable will also point to that same object. Let's see it here. Okay, print this and let's print this ID of this address. Okay, both are same. Is see there are two things, right? This variable name, this gets some space in stack.
Mm-hmm.
Okay, this stack has you can think it like this stack, whatever say 1 byte memory is allocated to this res, this will store a address of the object.
Okay.
Okay, as soon as this function return, this address is copied here and this variable is destroyed from the stack, but the object which is at some other location, which is at in heap,
Mm-hmm.
okay, that is still valid.
Okay.
And now this output is pointing to that uh,
Okay.
object.
Yeah, I got it.
Okay, so means in Python, uh, these variables, these get space in a stack, but the actual object which we talked earlier, that those objects get stored in heap memory. Okay,
Okay.
so means if you remember our previous session where we discussed object referencing thing,
Yeah.
okay, how variables are stored in Python. So you will be able to relate it now. You asked one question there also, means these will get some space somewhere like that, right?
Right. Yeah.
You asked one question, so now I think that you will get a clarity that these variables will get space in stack. These variable names,
Mm-hmm.
more specific, these variable names will get space in a stack, and they will point to an object which is residing in heap memory.
Okay.
Okay, and this is a proof. Yes, this that actual object is is still valid. Okay,
Okay.
so let's see about global variables. Uh, so, global statement, and it's non-local. Non-local we'll see later on. Okay, these are cousins are only things that are remotely like declaration statement in Python. They are not type or size declaration though. They are namespace declaration. Namespace means where in which scope you are defining a variable. Okay, that means say in this function you are defining, you are creating this variable. So namespace for this variable will be this function. Okay, so it's a block, you can say, in which block this variable is valid. So that block will become a namespace. Okay, so global names are variables assigned at the top level of enclosing module file. So when we create a global variable, those are accessible throughout the file. You can access those variables any function anywhere but within that file. You cannot access these global variables from outside the file. It means in a larger project there will be multiple files, right? And if you are creating any global variable, you cannot in one, let's say x.py, in x.py you are creating one variable. You cannot access that variable in y.py. Okay, you cannot access directly those. Okay, there are other ways to do that, which you'll see later on. Okay, global name must be declared only if they are assigned within a function. We'll see this in code. Global names may be referenced within a function without declared. Okay. Global statement consists of keyword global followed by one or more names separated by commas. Okay. Let's see that. Let's create two variables. Now, this first one and second one. These two variables are not inside any block. So these two are global variables. After creating these two variables, you can use anywhere in this file these two variables. You cannot use these before this. Means like if first one is here and if you want to use it here in this line, you cannot do that. It will give you error. That because it will not know what the first one is. So after you create a global variable, after that you can access this variable anywhere in the code. Okay. So let's create one function. Again, this function will also do the same thing. Okay. Which okay, it will do the same thing. That it will find the intersection of two arguments passed. Okay. Now let's try to access this global variable. First one. Let's print this. So you will see I can access this first one, this object here. Okay, I can access this. It's printing. Okay. So to access these variables, we need not to write any keyword, global keyword. Okay, this line. Global name may be referenced within a function without being declared. Means you can use this function, use this variable without declaring it. You can access it, but you can only read it. Okay. If by any chance you want to update this function variable, okay, and let's print it outside also. We don't need this output. Okay. Now, what we'll do in this function is we'll update this first one with this new value. We'll print it and then we'll print it here. So we'll see what happens. So what happened? This dummy, this first one got assigned this value dummy, this, it printed dummy, but as soon as this function returned, this global variable is same. Okay, this global variable is not updated. Okay, why it is? So there is a rule in Python. Let me introduce that rule here. It's a name resolution. It's a LEGB rule. What this rule says, when you use a unqualified name inside a function, Python searches up to 4 scopes. The local scope, then the local scope of any enclosing def and lambda, then the global scope, and then the built-in scope. Okay, so first it will check in local scope, then in the local scope of any enclosing def or lambdas, which we'll see what actually this means is. After that, in global scope, then in built-in variables. So there are some built-in variables in Python. So it checks at the end in this built-in part. So when we created, like we wrote this line, what happened? Python found this is a local variable. It is defined inside this function. So Python will consider it as a local variable. It will not go outside this function to find any other definition or something. It found it here. It printed it here. Now, as soon as this function returned, this first one got destroyed. And this first, because we have a global variable means a variable in global scope, it is printing this variable. Okay, is it clear?
Yeah, Dheeraj. Yeah.
Okay. So if we want to update this global function, what we'll have to do? We'll have to declare this variable as global inside the function. Okay. So let's see. Now we updated it inside this function. It printed dummy, and when we call this line again, it called dummy because this variable is updated now. Because we said by this line, Python get to know that hey, Python has to use a variable which is in global scope. So don't search in local or anywhere. Search in global scope and update that memory. Okay. So likewise, you can update your variable which is in global scope. So need to write this if want to update the global variable, or first will be treated as local. First means this first one. This will be treated as local. Okay. But there is a reason in this. People say, developers say in Python community that we should not use global variables everywhere. Okay. So why? By default, name assigned in function are local. So if you want to change name outside function, you will have to write global statement. We saw that this right. Now let's consider and this example. Can you guess what will be the output of this? Yes. What will be the value of x after this? We can we as get to know what will be the value? No, not with these line, only this line of code. We'll have to know which function we are calling first and which function we are calling second. If we know this, then only we'll be able to tell what will be the value of x after this. This is the something we will have to, as a Python developer, we'll have to take care that when we'll create a global variable and we are using it in multiple functions, in that case, we'll have to remember or we'll have to be more careful when we are updating this. Okay, and this is the reason it is suggested not try to use try to avoid using global variables as much as possible. Use local variables, pass them as a argument, as a parameter you pass to the functions, but don't use like this. Okay. So this is one suggestion. Now let's see what is a built-in functions. So there, to see the built-in functions, we'll have to import one module. Yes, we had not covered modules yet, but for now, just I'm showing just to show you guys that we have languages. Okay, you write something in a file, you create it as a module, and you can give it to someone else to use that module. So you can use that. Okay, so this module, this gives information about built-in variables which we have. So you can see we have all these built-in variables, built-in functions. We saw this zip, tuple, sum, str. You can see we saw all those things, right? Max, min. So and if I show you, uh, you will see all the errors whatever file exists, error, index error. We saw this index error, save while execution. Okay, and there are all the errors which we used to get if anything goes wrong. You can see all those here. Type error, right? You can see index error. Somewhere it will be indentation error, index error. So all these are built in, and using this module, you can see all these built-in variables, built-in functions, and everything. Okay, there is nothing much to go in detail about in the built-in variables. For your interest, you can go into this, you can see what these are, but for now we will leave it till here. Okay, so in Python you can write nested loops. Okay. So what it is, enclosing scopes, okay, which we saw a couple of times here in this LEB. We saw that this enclosing scopes of any enclosing depths. Okay, so this enclosing scopes are sometimes called statically nested scopes. What this nested scope is, a reference looks for some name X first in current local scope, then in local scope of the lexical enclosing function in your source code. So means these statements may look something vague right now. Let's look it into code. Let's create one function, print message. We have a global variable number. Okay. Now in Python, we can create a function within a function. And we can do this because def is an executable statements which will create one object of function. Okay. So this line will create one object, function object, and assign it to printer, this name. Okay. So this we can do in Python and it is totally valid. Let's see this. See, it is valid. So what happened here? Let's see. This is a print message. Okay, we passed 9 to it. Okay, 9, and we used that same number here. Okay, it printed 9 here, then 9 here, then it printed 10 here, because this is a in global scope. This is, we are in global scope, and this is a lexical enclosing scope. We'll see how it is. Now let's see, we'll write number equals to 3. Let me add some strings so that it will be easy to understand. Okay. Okay, so see what happened when we called this print message with value 9. It came inside, it created one object. Okay, in this object, number is a local to this function, which to this number we assigned 3. Okay, now we call this function, okay, which is only valid inside this print message underscore message. So we are calling this printer function. It will print number which is local to this printer function. Okay, so it will print 3. Now after this printer function, we returned from this function. Now we are in this scope, so we'll print, this will print number which is here, passed here. So it will print 9. Okay, and this is a global scope, so it is printing 10. So for now this line is not in focus. So what is happening? What is the enclosing scope? Enclosing scope is if we have a function which is inside a scope. Inside a scope means inside another function. Okay, and we are now when we create any variable, it will first search into this scope. Okay, when we are using any variable here, it will search in this scope. It if Python finds this in this scope, in the local scope of this printer function, it will use this one, this local one. When Python do not find number in the local scope, it will search in this scope. Here it finds this number. Okay, it finds this number here in this enclosing scope. It will use this number. So now, if we only want to use this variable, we can do that without any problem. Okay, we can do that. But if we want to update this variable, okay, if we want to update this number variable, it will not. It's same, still same. It is not updating this number variable. So if we want to update this, we'll have to use one keyword, non-local. Non-local. What this keyword will tell to Python that search for this variable inside the enclosing scope, means in the upper block, nearest upper block. Search there, and when we do this, you will see it is updating this number variable. Number clear? Are you guys there?
Yeah, Dheeraj.
Yeah. So it is clear till now?
Yeah, Dheeraj.
Yeah, Dheeraj.
Okay. 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 This enclosing scope lookup works even if enclosing function has already returned. What it means? Let's say we have this function f1. In this we have one variable x equals to 88, and we have one function f2, and we are printing inside this. Okay. Now this f1 will return this f2. It will return a function object. Okay. So if we'll make this statement, if we write this statement, okay, so action will become f2. Okay, and if we call this action, it is printing 88. Okay, because what is happening, this f1 is returning an object f2. Okay, so this f2 will remember what was the value of x of its enclosing def scope. It remembers that f1 returned from here, but this f2 remembers this value. Okay, and remember, this is not a call, this is a return. So we can see, and it's here also. this F2. Okay, we are getting same object which is created here. That function object is returned, and we have collected it in this action, and we are going to use it here. Okay, so so what is these nested functions remembers the scope, is the enclosing definition scope. Okay. Now there is one concept comes closer, factory functions or closures. But the closer is closer or a factory function. The former described is this. Closer describes is describing a functional programming technique, and later one is a design pattern. Okay, factory means in other languages, if I talk, it's a kind of factory design pattern. Okay, let's create one function maker. It will have a nested function inside it, action, and what is happening is maker is taking one parameter, and action is also taking some other parameter, and it will do x to the power n. Okay, and this function is going to return object of action. So if I write this line, okay, just a minute. Yeah, if I write this line, what will happen here? You can see this is a object, so it printed something function maker dot locals dot action as this. This it printed the address. Okay, now if I call this f with a parameter 3, what will happen? What it did, you can see this maker, we passed 2 to this maker. It created one object where n is equals to 2, and after that when we called this means after that it returned one that object to f, and we called this action which this returned object with some parameter 3. So this 3 is actually x, and this 2 is passed for n. So it will remember it, and it will do x to the power n, means 3 to the power 2, and it is returning 9. Third 4, it will return 16. So what is happening? This f is remembering whatever we passed for the first time. If, for example, if I pass it here 3, say it will do a power of 3. So now for the first time we did this, and after that we can pass any number of variable, means any value, it will behave like that. Okay, here in this line, The get back is a reference to the generated nested function, the one created when the nested def run. And in this line, we invoke the nested function. Sorry, this line. We invoke the nested function, the one called action within maker. Clear? Here, yeah, nested function remembers integer 2, means whatever we are passing here, 2 or 3, the value of the variable n in maker, even though maker has returned from here, but still this f will remember this value n we passed, and based on that it will do operations. Okay. We can have function like this and with some default value. Okay, if we have f3 and we have x is equal to 99, and inside this we have one f4 function, and this argument has a default value, and this x is here, and we are just printing it, and we called it here. Now if I call f3, it will take this as a default, means we need not to pass anything here. Means if we are not passing anything to f4, if let's say we pass something here, it will print 100. If we don't pass anything here, this will be a default value, so we can use it like this also. Okay, is it clear till now? This is this is all about scoping, variable scopes. Okay, and there are few lines which we already discussed about non-local thing. So this non-local statement, this got introduced from 3.x onwards. Before that, this was not available, which has meaning only inside a function. This statement allows a nested function to change one or more names definition in a syntactically enclosing function scope. Now I think everyone knows what this enclosing function scope is. The name listed in a non-local must have been previously defined in an enclosing def when the non-local is reached, or error will be raised. What it means is, when we create a non-local, when we write this variable should already be created before in this scope. In this case, we have this number is already defined here, so it is working. If it is not defined, if we let's say create it like something 1, okay, this will give error because it is not defined in this scope. Okay, so it will give error. So this number should be defined earlier, and remember, this is not a definition or like beforehand declaration or something. This is just telling a Python that find this function in this scope. These non-local and global, these keywords will just tell Python in which scope Python should look for these variables. These are not declarations. Okay, remember this. These are not declarations. Okay. So this was all for today. Okay, from my side. If anyone have any question, you can ask me here now.
Yeah, Dheeraj. So I watch in between the flow. Actually, I was a little bit diverted to this production mode. So anyway, can you please share the previous ones also so that I can go from the beginning and I will ask if any clarification.
Yeah, all the recordings are already on YouTube. I will share the link,
Yeah, thank you.
YouTube link. You can go through those videos.
Sure,
Okay. Yeah.
sure. Yeah, thank you.
Yeah. Anyone else have any question, any query?
No, Dheeraj.
Okay. So,
Mm,
Dheeraj, have small doubts.
yes, 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 yes.
See, like in C or C++, we call from one function from one another class, right?
One function from,
Another file. From another file, we can access,
yes,
and
okay.
also we can restrict that file to that location only, like static and all those things. Do you have anything? Do we have anything like that in Python?
Static means
Like
I'm not
invisible
understood
to
how.
that, only visible to that file only, and I cannot access in other files. Like
See, in Python,
in
in
Python, as far I know, in Python's each
Mhm,
file has like a module. I can import that module and I can
mhm.
access the functions. Right.
Yes, yes,
If I create some class and all those things, those classes I can make functions through the classes. I can access the functions of the class.
yes.
So what I'm asking is, in some
Mhm.
functions, I cannot give permissions to the user from that module, right? See, in our
Okay,
C
so
also,
you mean to is what I understood is you are asking. Let's say there is one file, and there we have 4 or 5 classes, and you want to restrict one class which should not be used outside.
no, not even a class also, and function. I'm saying
Mhm,
not majorly class. I was
mhm.
saying a function. I
Okay, so
declared a
that
function
only
locally.
that function should not be accessible in any other file in any other module, and remaining you can access something like that.
Yeah, yeah.
Okay, means
But
right
that
now,
function
yeah,
I can use internally. I cannot
yeah,
use.
internally in the file you can use, but you cannot use outside, right?
Yeah, yeah. That like a
Okay,
static functions we create in C++, right?
okay,
Like that.
okay.
Like that.
Right now I don't have answer for this.
Mm.
Okay, but I will come with the answer in next session for you.
Okay, then.
Okay,
Thank
I
you.
will write it down and I will come up with in the next session with the proper answer and explanation how you can do. Okay,
Okay.
yeah,
Okay, then. Thank you.
okay, yeah. So I will stop this recording right now.